I sort of want to explain, if I want to give you a sort of one-word sentence, I want to explain why people will vote for sort of traditional patronage parties even when they hate the party. So that's sort of why I got into this. I'm going to present a fairly general model of voting behaviour, the sort of standard rational choice voting model of, you know, what effect am I going to have on the outcome of the election, and that's why I'm going to vote. Let me give an introduction. This is a quote from a book discussing the Chicago machine under Mayor Daley, the senior one, not the junior one. And it's sort of machine co-ops, those are emerging leaders in the black and Spanish communities who are willing to cooperate, reallocating perquisites and prerogatives to the blacks and the Spanish-speaking, taking them from the ethnic groups such as the Jews, the Germans, who no longer support the machine as loyally as their fathers did. So the basic thing I want to think about is parties handing out rewards to supporters. And so the key intuition to the paper is going to be that parties are going to reward loyal groups of voters. Those who deliver votes for them are going to be rewarded. They're going to get given pork, or they're going to get given local public goods. And so I'm going to assume that you can't target individuals, because I'm going to assume that votes are anonymous. But you do, for example, see votes at the precinct level. So we can make life really simple. I would like to generalise and talk a lot about all kinds of groups, but just to keep the model really simple, just think of this as two precincts. So we're going to have an election, and we've got two precincts. I can't observe how individual votes, but I do get to see the vote totals for each precinct. And then I have some good to allocate. So let's say I'm going to renovate a school. I only have money to renovate one school, but I can choose which of the two schools I could do. I could do it in the first precinct or the second precinct. And that's going to be the story here. So individuals, when they vote, they're going to be pivotal in two events. They're going to be pivotal in who wins the election. So this is the classic way, the sort of standard rational model of the rational choice of the voter. This is a very standard way to think of, am I going to have party A win or party B? And I'm going to refer that to as outcome pivot, because it's going to affect the outcome of the election. So I'm pivotal in which party wins. And that's the traditional way that people have thought about pivots. But just as David was talking about earlier, I can be pivotal in other events. For him it was, do I give the party such a landslide victory they can ignore the policy wishes that I want? For me it's going to be, what's the allocation of the prize? Which of the districts which of the precincts is going to have the school renovated? Is that the prize pivot, I'm going to sort of argue that in general, you're going to be more pivotal with respect to the allocation of prizes, then you're going to be pivotal over who determines the outcome of the election. That's sort of going to be the sort of bang for the buck here. Is we traditionally think people vote for A or B because they want the Republicans or the Democrats to win. I'm going to argue that you're actually much more pivotal in the distribution of which school gets renovated. And I don't really know I don't know the answer to your question because I'm not quite sure. This is an example of an earlier paper that I did with Bruce that's in the BJPS, and this is sort of a very simple, stylized example, because I want to make sure everybody, if everybody gets this example, then the rest is just some maths, and I did put in all the algebra that David took out. So, but let me give you a real simple example. So I'm going to have a very simple polity. I'm going to have 3 villages, each of which have 3 voters. And we're going to think of some party A. I'm going to think of these as the incumbent, the bad, horrible incumbent patronage party that everybody hates, but yet there's going to be an equilibrium where everyone votes for them, because they're going to make the simple promise is that we're going to build a new hospital, and we can build it in any one of these villages. We could put it in village 1, 2 or 3. We're going to give it to the most supportive village. And so I want to think about how can you be pivotal? So let's take one of the voters in the first village, and think about how the other people in the other 8 voters are going to vote. So let's suppose in my group 2 people have voted for A, and in both of the other villages everybody votes for A. So there's already 8 votes for A. So I'm not pivotal in the classic way of affecting the outcome. A has already won the election, independent of what I do. If I vote for A, then all the villages deliver 3 votes. So I have a 1/3 chance that A is going to give me the prize. And if I vote for B, or I abstain, and this simple model there was no abstention, but if you abstain, the chance of winning the prize is 0, so in a sense I'm pivotal to the extent of 1/3. Okay? So let's think of another example we can think of here. There's 2 votes. A's already won the election, it's got 6 votes. If I vote, I'm definitely going to get the prize in my village. But if I don't vote, I've only got a 1/3 chance. So I'm 2/3 pivotal in this case. We can think of other events, for example, here where I could be both prize pivotal and outcome pivotal. So 1-2-1, so my vote is pivotal in the election, and it's also pivotal in the allocation of the prize. And we can think of, there can be eventualities where I could be outcome pivot and not prize pivotal. But this is the intuition I want you to have, is that I can have 0 influence on the outcome of the election, but I could be pivotal in terms of the prizes. And what I'm going to argue, I mean, this example here, I have 3 voters, we could take n voters, and there's an equilibrium where everybody votes for the incumbent, provided 1/3 of the prize is bigger than the cost of voting. Everybody wants to vote for the incumbent. So what am I going to do here? I'm going to do a Poisson voting model, so I'm going to have a random population. I'm going to focus mainly on the sort of turnout decision here. So groups, I want to define groups technically to be rewardable and identifiable, by which I mean I know how much support came from a group, and there's a way I can selectively reward a group. So I would like to generalise to think about sort of ethnic groups or religious groups or occupational groups, but for the purposes of today, just think of 2 precincts. And I count the votes by precinct, so I know the support of the precinct, and I can renovate the school in one precinct or the other. Okay, so that would be, just to keep everything really simple, just stick with that. And I'm going to make the prizes contingent, and I'm going to just focus mainly on, or exclusively in this particular paper, on the winner-take-all rule. So we're going to give the prize, we're going to renovate the school in the precinct that gives us the highest vote total. So here are some of the details. Technically, each of the voters can vote for A, they can vote for B, or they can abstain. Voting is going to be costly. I'm going to have some on average, I'm going to have NT voters, then divide them into K groups, but let's just think of 2 precincts for most of what we're going to do. And the actual number of voters is going to be a Poisson random variable. Okay, so this is a very standard framework. So the contingent prize allocation rule is, I'm going to say that if we think of people voting with some average probability they're going to vote for A, then it turns out the number of votes for party A in each of the groups is going to also be a Poisson random variable. Let's just call it AK. And you're going to get a prize in group K, and the prize is squiggle. I have no idea what that Greek letter is. I always call it squiggle. Okay, you get squiggle if it turns out that your votes are the maximum of all the groups. So actually, technically, you could have, if 2 groups have the same maximum, they could both get, I'm going to have them both get a prize. But this is going to be a low probability event. It's going to be costly to vote. I'm going to assume people have policy preferences. And these are really not going to be especially important in this model, but so we just think of how much do you prefer party A to party B, and I just drew a normal distribution here. Basically, people who like A the most are going to vote for A, and people who like B most are going to vote for B, and the people in the middle are going to abstain. But these are not in some sense going to be sincere preferences, and indeed what I sort of want to do is push this over here. And that's going to be sort of the objective. But that's just to give you some idea about why people vote. And so let me give you an outline of what I'm going to do. I'm going to talk a little bit about how we can estimate the prize pivots and the outcome pivots. So the prize pivots, the probability influence the distribution of the prize. The outcome pivots is the probability you alter the outcome of the election, which person wins, A or B. I'm going to tell you that equilibrium exists. And then since everybody else in the literature, well, this is a big literature on rational voting, everybody else focuses on the case where people care just about policy. I'm going to do the exact opposite and focus on the case where people only care about prizes. Because that seems to be the other limiting case. And pretty much every substantive result I'm going to go through will just be a very simple extension of this prize-only case. So doing the prize-only case is a little simpler and everything follows. I want to talk a little bit about asymmetric turnout, because it turns out if you have more than 2 groups, it's very hard to support asymmetry. So I'm going to talk a little bit about numbers of groups, number of factions within parties and things like that. And we're going to talk a little about Duverger and asymmetry in group behaviour. I'm going to talk a little bit about how prizes affect turnouts in both competitive and non-competitive elections. And then I'm going to get my hands up to full speed, because This is not really formalised, but I want to talk substantively, because I'm a political scientist, so I don't do math so good. I'm going to talk a little bit about migration between groups, because I want groups to be endogenously defined in some sense. Think about people moving, and I want to think about how politicians organise groups. So, you know, when you take a city, how many wards do you make in a city? I want to think about those kind of questions. Okay, so that's sort of the outline. So let's go with the outcome pivot. This should be I'm assuming, I mean, many people in this room have written on this topic, so yell if you want me to slow down, but I'm going to define the outcome pivot is the probability that A wins if I vote for A minus the probability A wins if I abstain. So this is simply the probability that the number of votes for A equals the number of votes for B, so I break a tie, or my group is losing by 1 and I create a tie. So this is very standard. It turns out, since these things are going to be Poisson distributed, if we think there's some probability people vote for A and some probability people vote for B, then the number of votes for A and the number of votes for B are going to be Poisson random variables, and the difference between Poisson random variables is Schelem distributed, which I looked all of this stuff up. I didn't know any of this stuff, but it turns out Schelem distributions have this Bessel function thing in them of the first kind, but I can nicely approximate those large numbers with exponentials. So there's an exponential, there's a nice simple expression here. This is exactly the same approximation Myerson comes up with. The key here is, what's the outcome pivot? Well, it's got this 1 over root n in the denominator. So as populations get big, the pivot probability go down to 1 over root n. But we also got this exponential term, so unless the elections are tied, I mean, statistically people are voting with exactly the same probability. As soon as this even if you get a 51-49, as soon as we get a large electorate, this exponential is going to drive these prize pivots to very small numbers. So that's very standard. I'm assuming everyone's looked at that one. What I'm introducing here is a prize pivot. So what's the probability that my group get the prize if I vote for A versus the probability my group get the prize if I abstain? Okay? So simply it's the probability that, well, if I think of everybody else in my group producing this random variable AK votes for party A, and I throw my vote in, it's the probability that this is bigger than ever is at least the maximum. And if I don't do it, it's if I don't throw my extra 1 in, it's this. So we can just imagine it's the difference here. This is simply, so since these are Poissons, we can think of just summing over all the possible number of votes my group could have. And this is the CDF of the product of the CDFs of all the other groups. And so we can just get this expression here. So this is, in some sense, if I vote for A, my group's going to win when all the other groups' maximum is AK plus 1. And if I don't vote, I can only beat them when they've got AK. So this is sort of the expression. This is going to be horribly and ugly. Turns out, if there's only 2 groups that are voting, I'm going to call A-active groups, groups where there's a positive vote probability for party A, then I can just use exactly the same sort of approximation I just used for the outcome pivot, because then there's going to be 2 Poisson random variables, and I can make the Schelem, the difference is Schelem distributed, and I make the same approximations, so I'm getting a very similar thing. So the lambdas here are expected turnouts. So I've moved from N voters voting with probability P to these being turnouts, because otherwise I ran out of space. Okay, so that's the definition of a prize pivot. Equilibria exists. So how do we find these? Well, what's the problem? We're basically going to find the type of person who would be indifferent between voting for A or abstaining, and that's simply that the cost of voting is going to be equal to, well, this is how much they like candidate A relative to B and their influence on the election, plus how influential they are in terms of the pivot. And if they vote for B, we could think of parallel expressions. And I sort of drew the nice little normal picture, and these are just simply the thresholds that will make people indifferent. So, equilibria exists. I don't think anyone's too shocked about that. Let me show you what these things look like. So I've done a symmetric example here. I just supposed 30% of people are voting for party B, and then I wanted to just draw pictures of what the pivots look like with I think of the probability of everybody else in all the other groups voting with probability P for party A. Well, the outcome pivot, if there's a big difference between how many people vote for the expected turnout for A and B, the outcome pivot is virtually 0. So the outcome pivot just spikes here. But the probability of being given a prize by party A has this function of being 1 over root n, but we don't get this spiked behaviour. This is going to be sort of the intuition. Okay, so this is sort of the story is, this is a standard story we see unless elections are really close, the outcome pivot is basically 0. So if 50% of people vote for party A and 30% of people vote for party B, the probability of being pivotal is effectively 0. Okay? But if both there are two groups and both of these groups have 50% of people voting for A, I'm still pivotal in terms of the distribution of the prize. Subjected to this talk before, so this is my global proposition, and I know technically most of you are better maths than me, so you don't usually go by things being self-evident and empirical observation as a means of a proof, but this was the theorem I worked out while I was here. Life is too short not to drink good wine with interesting people, and there's an obvious corollary here, so anyway, that was the result I worked out while I've been here. But I should probably get back to the results I've worked out before I got here. I want to talk a little bit about the relative size of prize pivots. So this is the prize pivot for party A versus the prize pivot, for group 1 versus group 2. And I'm just going to put it in terms of lambdas. And if I was to expand this out in general for more than 2 groups, this is the expression, and basically you can factor it out into 3 terms. So these making comparisons here between group J and K, lambda being the expected turnouts, for the lambdas being the expected turnouts. So I can factor it out into comparisons between groups J and K in terms of turnouts, and these are probability mass functions for the Poisson, and sort of CDFs and PMFs of all the other groups. Okay? The advantage is if only 2 groups are A active, this is 1 and these things are 0, so the bottom terms are a lot of the bottom terms are going to drop out. The theorem we have is if basically there are only 2 A active groups, there's only 2 groups that are voting with positive probability for A, then the group with the smaller expected turnout has the higher pivot. Okay, this is a result a lot of other people have found, and I'm blanking, the guy at Berkeley has this, John Morgan has this came in, Krishna and Morgan have this result pop out too. So when there's 2 groups, the group with the smaller expected turnout has the larger pivot. But I'm going to show you in a minute, and I can sort of let you know why. In general, this result doesn't hold. It turns out the first and second terms in that thing I just showed you, the ones that are red, they're negative in the sense that the bigger group has the smaller prize pivot, but the third term has these other things, if you factor it all out, which are positive. So in general, which group has the biggest prize pivot is ambiguous. If there's 2 groups, I know the smaller one has the bigger prize pivot. But I'm going to tell you in a minute, if the lambdas are big, the second term is going to be small because it's the product of 3 probability mass functions, and the others are the products of 2 probability mass functions and 1 CDF. So this is relatively smaller, and I can show, this was the big thing that took me forever, is that the first and third terms sum to something positive. Which I'm going to show you in just a minute. That has sort of implications. So let me quickly tell you about the prize-only equilibrium. So I'm going to assume there's no policy differences. So that's CDF over so everybody is indifferent between the 2 parties. I'm going to just make life really simple. B isn't going to hand out any prizes. A is going to hand out a prize that is bigger than the cost of voting, and then I can give you the following results. This is only caring about prizes. At least 2 groups actively support A, and the level of support from the 2 parties is the same. Okay, so how does this work? Well, the outcome pivot is 0. Effectively, nobody cares about this all drops out, all the policy stuff. So the vote calculation is simply, do you care about the prize pivot has to be equal to the cost for both groups. Well, since I just showed you the only way to get the prize pivots to be the same is to have the same turnouts, they've got to have the same turnouts. There's a slight exception if one group actually runs out of people. It's like expectation too small, but let's not talk about that. What I'm going to tell you is with two groups, you get this negative feedback, is if one group gets too big, its prize pivot drops, so people have less incentive, so it's sort of self-equilibrating. If we've got three or more groups, we're going to get this idea I'm going to tell you about positive feedback. So, let me tell you about this positive feedback. This basically comes from that nasty expression I showed you for the difference in prize pivots between two groups. When the lambdas are big, the first and third, the second term is going to be small relative to the first and second, and the sum of the first and second is positive. Okay. So let's think about turnouts. I'm going to make group 1 to be row times group 2 and all the other groups equal. So all the groups are about the same. And I'm going to say what happens to the prize pivots, the relative prize pivots of the group as I start making one group slightly bigger than the others. Well, it turns out its prize pivot is going to get larger. So if I can get one extra person in my group to sort of any expectation join in, it suddenly makes the prize pivot go up in my group relative to the other groups. So in equilibrium, in a sort of dynamic sense, what would people want to do? Well, more people would want to join because all of a sudden we've got a bigger chance of winning the prize. They're more influential on the prize, so you get this positive feedback, so more and more people would want to join. So we've got 3 or more groups voting. Being A active is a knife edge case. So I can draw you a nice picture of that. This is sort of a related example to what I just did. Let's suppose initially there's 1,000 expected voters in each of 3 groups. And then I just want to introduce some asymmetry and plot the prize pivots. Group 1 is going to have in expectation 1 plus delta times the middle group, and this one's going to get smaller. And so there's about a 1% difference. So I increase the vote share, the expected number of votes for the bigger group by 10 as I move from the left to the right. Okay, and this group goes down. The key is the bigger group gets the bigger incentive to show up and vote. So this is going to be obviously this is going to be very unstable. So we're not going to get equilibrium except in this knife edge case where any perturbation in expected turnouts, equilibrium with more than 2 groups is going to be unstable. What does this tell us a little bit about Duverger? Well, there's sort of a Duvergerian result, not in terms of the number of parties, but in terms of the number of groups. So if we've got a single active group, we've got one group supporting party A, well, the prize pivot's really small because they already know they're going to win the prize. There's only one group voting for A, so the turnout's going to be really low. That doesn't seem a very sensible place. We've got 2 groups. They're active and they're stable, and the vote shares they have, the expected turnouts are going to equilibrate. If one gets too high, then their prize pivot's going to drop, so they're going to come back down. So it's going to be a nice stable situation. And 3 or more is going to be unstable. So what do we see? We got between 2 and 4 groups being active, because it could be, for each party, there could be no more than 2 active groups being stable. But there are 2 parties, so we can have 4 groups. Right? It could be the 2 precincts. We could have 4 precincts, and 2 of the precincts vote for A with the same expected vote turnout, and 2 vote for B. That would be a stable. So we have between 2 and 4 groups. And I'm going to say per prize, because I'm going to come back to per prize in a little bit when I think about organisation. So that's Duverger. But now let's think about this in terms of Downesian competition. And I sort of want to make the following claim. So if the candidate's positions converge to the median voter, well then we're prize-only competition. All that should matter when we think about rational voting has got nothing to do with candidates. We should only be thinking about distribution of prizes mattering. And if the prizes are big relative to policy, and I'm going to give you some idea of scaling on that in a minute, there's no incentive for the parties to converge. Because people aren't voting on policy, they're voting on prizes. The policy doesn't matter, so we shouldn't expect convergence. Okay? So that's, I believe, the 999th explanation for non-party convergence. Okay, so let me talk about some substance because I don't want to do any more maths. I'm just going to draw you a little graph here. And so what I've done is I had 100,000 voters and I divided them into 2 precincts. And the cost of voting is, I think, in this game is 5 cents. The distribution of preferences is standard normal. And I wanted to think about what was the turnout at different prize sizes, just to illustrate the effect of prizes. So if we have no prizes, 1/4% show up, so very small turnout. This is a story we should all be fairly familiar with. So now I wanted to say, let's make the prizes 400 times the cost of voting, which is actually twice the standard deviation, twice the variance in the policy distribution. Okay, just to give these things scaling, and I get 27% of people showing up to vote for each group. Right, so these are, and I don't quite know, how much do you value having your school renovated is relative to the cost of voting. Let's say that's 400 times, that would get 27% of the people to show up in an electorate of 100,000. Okay? So I want to spin this round and think why the prizes work so nicely. I want to think, what would the variance, so I take out the prizes again, make the prizes back to 0, and think, how much variance would I need in the distribution of preferences to induce 27% voting with a normal distribution? Well, I'd need the variance, the policy variance in a normal distribution to be 23,000 times the cost of voting. So just, I never really want to push these comparisons, but you sort of get the idea of increasing prizes. Turnout is increasing at a quadratic rate. But this is what I really want to talk about, is why we get dominant parties. So I want to work out why people would vote for the PRI in Mexico. They kept going for years and years after everybody realised it was a corrupt, horrible organisation that didn't deliver anything. Why would you carry on voting for it? Well, the answer I'm going to claim is they can hand out more prizes than the opposition. So I'm just going to do a very simple example here. Party A, let's call them the PRI, can hand out 16 prizes, and Party B can only hand out 4. Okay? So it's going to turn out, in this case, the outcome pivot is going to be effectively 0, because 16 times more people are going to vote for Party A than are going to vote for Party B. So I've just simply done here, this is the turnouts, the probability of voting for the party, and I've reduced this is the cost of voting, so when the cost is high, very few people vote, and the costs get low. But the key is, 16 times more people will vote for the party handing out the larger prize. I mean, this is 4 times bigger, it's a squared relationship. So I got the turnout ratio is 16 times bigger. So there's some substantive things I'd like to think about here. So I like to think about socialisation phenomena. So this sort of reminds me of Sprague's work, is that if you live in a district where everybody votes Republican, even if you come in as a Democrat, you're not going to influence the outcome of the election, but you might want to go vote just like all your neighbours. So his idea is socialisation. You sit around the dinner table and have wine with them, and then you adopt their political views. I'm just thinking, well, you just know that I'm not going to affect the outcome, but I'd really like a local politician to think that we're really important to him, and therefore he's going to build me a new school. And so that's my idea. That's my alternative for this. Turnout's going to differ by groups. So sort of groups that are highly supportive are going to have bigger incentives to turn up and vote. Groups that are unlikely to have little chance of being up there in terms of most supported group, people are just voting to influence outcomes. And I want to tell you why reform is so hard here. So even if we all agree that we hate Party A, this is very much going back to the story that David just had here, right? We would really love to get the party out, but conditional upon not being able to get the party out, we'd really like to win the prize. So the worst thing is that the party stays in, but we don't get the prize. So I'd love everybody else, all the other groups, to vote the incumbent out, but I don't want to do it myself. Because if we don't succeed in voting them out, I don't get the prize. This is why reform is so hard. Everybody may agree, but nobody wants to be the group that actually does the voting out. And that's David and I are going to take his technology and put this problem in, and he knows how to do math better than they do. So let me start talking about that. So far when I talked about the asymmetry stuff earlier, I was talking about asymmetry in behaviour in terms of the lambdas, the turnouts being asymmetric. So now I want to think about the groups actually being of different sizes. So let's say I've got 2 precincts, I'm going to make one of them bigger than the other. Let's say I make this precinct 1 bigger than precinct 2. What's going to happen? Well, I know the equilibrium condition in terms of the vote share for A is simply, these outcome pivots are the same, and I can tell you a bit about the prize pivot. I can just rearrange this, and let's suppose the distribution of preferences over policy was uniform. You don't need this, but it just makes that maths really easy. I can get this very simple. I can turn that into that. Okay. So let's suppose this is positive. the election is competitive. Okay? Well, actually, let's do the easy case first. Let's suppose elections are non-competitive. This is effectively 0. Then these two things must be the same. How do we get those two things to be the same? We have to have the same turnout, the same expected turnout for both groups. Okay? So when we have non-competitive elections, two groups turn out at the same rate, even if the groups are slightly different sizes. I mean, they could be massively different, so you can't do that. Let me give you a picture of what that looks like. So here I'm just going to start increasing the size of group 1, so it's 60% bigger here, and I look at the probability of voting for A. Well, it just goes down so that on average both groups are delivering exactly the same number of votes. Because policy considerations are irrelevant in this case. Okay? What's the probability that the first precinct gets given the prize? Is 50%. Independent of how much bigger, until it gets to the point we run out of voters in some sense, but as group 1 gets bigger, it becomes no more likely to win the prize when elections are non-competitive. If I go back, if I make the elections competitive, then the group that's bigger turns out at has a lower probability of voting for Party A, but the number of people in expectation that vote for Party A is higher. Okay? So what does this look like? So look, this is the picture here. I'm going to start making group 1 get bigger as I go across to the right-hand side. What happens here when they're the same size groups, they're both voting at the same rate? Well, group 2 are voting at a higher rate than group 1, but the expected number of people who turn out for group 1 is higher. What does that mean? On average, group 1 is going to win the prize. Okay, now I'm going to put this down. So now I've got to wave my hands really fast, okay, because I've got no math, I've got no proofs for anything. What follows is now conjecture. Okay, so now I want to talk about why we would care about this. So I'm getting the windmill going, okay? So I want to talk about migration and group fluidity. So in a non-competitive case, the precise size of groups doesn't matter. So we've got relatively low migration. I have no incentive from leaving precinct 1 and going to precinct 2 or vice versa. Because when the elections aren't competitive, the exact number of people doesn't matter. There are no policy concerns. Sort of the intuition is, we know who's going to win, so turning up and voting, it's policy irrelevant, it's preference irrelevant. So we should have low migration rates. I have no incentive, and my group has no incentives to admit more people. Especially if the prize is perfect. Especially if the prize is in some sense what I'm going to call rival, because I just have to share it with other people. So groups, non-competitive elections, group identities, people have little incentive to move between the active groups, and we have no incentive to admit new members. So I now want to move beyond precincts to think these groups, if they were defined as racial categories or religions or whatever. Okay? I don't want to let people in. Okay? But in a competitive setting, the bigger group wins the prize on average. So now if I'm in group 2, I go, my group isn't getting these prizes anymore, they're always going to group 1. I want to move to group 1. And group 1, they say, come on over, let me redefine our ethnic caste, because if we define our ethnic caste to have more people, we'll be the most supportive group and the prizes will come to us. Okay? So one of my colleagues, Kanchan Chandra, looks at exactly this, is that how ethnic parties in India will redefine what ethnicities mean such that they can become, they've got entrepreneurs going around thinking about redefining ethnicity so they can bring in an extra group to make themselves bigger. This happens as incentives to welcome new members, but only when the elections are competitive. But there's a bit of a caveat. If one of the two groups gets too good at recruiting members, well then the elections are then the party's going to fail. Because if we go back to the picture, just to give you the sort of intuition here, as one group starts winning the prize more often, the probabilities of voting for the parties from both of the groups went down. Because the intuition being here is the prize pivots for both groups are going down because the competition for prizes is less competitive. So fewer people turn up and vote for Party A, so the election is going to be, we've got this sort of self-limiting thing. If the one group gets too good, it's going to kill the vote share for Party A. party B is going to win, and then the election's not competitive, so we can't carry on being sort of a self-limiting process. So that's how I want to think. That was the big hand wave as to how people organise themselves between groups. So I want to think about how politicians organise groups. So I've been reading a lot about Chicago. Chicago has 50 wards, and the obvious question is, why do you have 50? Why didn't you have 100 or 200 or 3? Okay, and so I want to give you some intuitions as to how to think about organising it. So I'm going to start with 16 primordial groups. We start with 16 just because it's one of these things that goes with 2 quite well. So, and I want to think if I'm a dominant party, so I'm not going to worry about policy, the outcome pivot, it's just the prize pivot. I want to think if my goal as a party leader was to secure 60% of the vote. I want 60% of people to vote for me, because that makes me really safe from any challenge. How should I best do this? Well, I've just sort of told you that if I had a competition between 16 groups in equilibrium, only 2 of them are going to vote for me. So I obviously can't get to 60% by just offering a prize to 16 groups, unless they were absolutely perfectly balanced in size, but that's a knife edge case. But what I could do is I could organise them into 2 counties. So I can initially start with 16 groups, I can make them into 2 groups that can each contain 8 of the original groups and have one competition between 2 counties. Alternatively, I can have 8 counties, each with 2 groups in. Or you can see the other combinations here. So now what I want to think about is what's the best way to do this, and there are a bunch of trade-offs. So if you think of the number of competitions, so this is just one competition between, this case here, one competition between 2 counties of 8 groups. That's perfect timing. Or I could have 8 competitions, 8 counties, each between groups of size 1, or original group size 1. Okay? So suppose the prize is non-rival. So this might be, we're gonna make the language of the winning group. We could think of English or French, right? Or Catalan and Spanish. How about that? Which would be a little more controversial, right? We're gonna do Catalan or Spanish in each of these counties, right? If I have one competition, then I'm going to have to produce the Catalan all the paperwork in Catalan or all the paperwork in Spanish. The cost of providing, I'm going to say, a non-rival prize is independent of the number of people enjoying the good. Because once I've written all the paperwork, the relative number of people enjoying the paperwork it's 0 marginal cost. When the groups are big, the pivots are inversely proportional to root n of the people. So this is size root 8. So this is how much I'd have to spend in a relative sense to have 8 competitions. I'd be better to have a single competition than have 8 smaller competitions when the prize is non-rival. Like a language group or something where it's a non-rival good. If it's a rival prize, just think of handing out cash. I'm just going to pay off everybody. Now I've got a trade-off. If I have one competition with group sizes of 8, I'm going to have to effectively pay 8 people. And the pivot is going to be inversely proportional to root 8. I could have 8 competitions. I still now have 8 competitions rewarding groups of effective size 1, but the pivot is much smaller. Oh, sorry, the pivot is much larger because it's 1 over root n, so it's proportional to this. So if I'm organising, handing out private goods in some sense, like renovating schools or building parks or bridges, rival goods, I want to hand them out at a local level. I want to divide the precincts up into pairs of precincts and let them compete. If I'm handing out a good like an ethnic good, religious dominance or something like that, or a language good, Catalan or Spanish, I just want to have competition at the national level or the provincial level or whatever, but I want to have it at the largest level. So this is sort of the distribution of how we do goods. And so this is sort of summary. Competition, I want to have competition between these groups, but everybody's voting individually rational. So I'm not having the group are committing to doing anything. Everybody wants to go along with the group. And I sort of want to explain persistent parties. So we've got fair elections does not mean accountable politicians. This is where I come in, because I like to study dictators. Okay. So elections, I want to have credible vote buying. I've got lots of turnout. People are. This is. See David Meyer, right? This is voters are pivotal in lots of ways, and I've argued that prizes are dominant. And I finished right on time, didn't I?
Yes. Questions? I think everybody needs some coffee. Thank you.